Assalamualaikum and hi to everyone. Welcome back to my channel. So in this video, we will continue on the example of the TDM, Synchronous TDM. So you can look at this example using Synchronous TDM. Okay, let's say we have 4 channels and we want to multiplex these 4 channels using the TDM. Each of the channel send 100 bytes per second. And we want to multiplex 1 byte per channel. We have 4. We want to multiplex 1 byte per each channel. So you need to show the frame traveling on the link, the size of each frame, the duration of the frame rate, and the bit rate of the link or the link. Okay, each frame carries 1 byte from each channel. So we have 4 channels. So in a frame, we have 4 bytes. So 4 bytes, when we convert into the bits, it's equal to 32 bits. 4 byte times 8 bit. So we get 32 bit per frame. So size of frame is 32 bits or 4 bytes. So because of each channel sending 100 byte per second, and a frame carries 1 byte from each channel, so the frame rate must be 100 frame per second. One channel has 100 byte, and then we multiplex 1 byte for every channel. So we will have 100 of frame. So the frame rate is 100 frame per second. Okay, the bit rate is 100 times with the bit. One frame we have 32 bits. So 100 frame that we have multiply with 32, then we get 3200 bit per second. Okay, you look at this figure. We have 4 channels. Each channel we have 100 byte per second. So when we multiplex 1 byte per each channel, so we take 1 byte from blue, 1 byte from pink, 1 byte from yellow, and 1 byte for green. We combine together in order to create one frame. So 1 byte, 1 byte, 1 byte, 1 byte. So total we have 4 byte. So in one frame we have 4 byte. 4 byte, when we change to the bits, it's equal to 32 bits because 1 byte has equal to 8 bit. Okay, next, how many frame that we can generate? So each of the channel has 100 byte per second. So that means it has 100 byte. And we combine 4 byte, 4 byte, 4 byte. So we take 1 byte, 1 byte, 1 byte, 1 byte, 1 frame. 1 byte, 1 byte, 1 byte, another 1 frame. So total, logically, you must have 100 frame. So you have 100 frame per second. Okay, so the frame duration 1 over 100. The bit, we have 100 frame, and each of the frame contain 32 bits. So 32 bits times 100 frame, it's equal to 3200 bit per second. So this one is the bit duration, this one is the this one is the bit rate, this one is the frame rate, this one is the frame duration. If the question asks about the bit rate, so 1 over 3200. Okay, the next example. A multiplexer combine 400 kilobit per second channel using a time slot with 2 bits. So we want to multiplex 2 bits. Show the output with 4 arbitrary inputs. What is the frame rate? What is the frame duration? The bit rate and the bit duration. Okay, so we have 4 channels, 100 kilobit per second, and then using time slot of 2 bits. So this link carries 50,000 frame per second, This one, 100 divided by 2. So you will get 50,000 frame per second. So the frame duration is 1 over the 50,000. The frame rate is 50,000 frame per second. And each frame carries 8 bit because it's combined 2 bit per channel. So we have 4 channel. 4 times 2 equal to 8. So per frame we have 8 bits. So the bit rate is 50,000 times 8 because we have 50,000 frame. 50,000 frame times 8 bits of within each frame. So total we have 400,000 bits or 400 kilobit per second. The bit duration 1 over the bit rate. So you will get 1 over 400,000 per second. Okay, this is how we try to multiplex using the TDM. We have 4 channel. So each channel we have 100 kilobit per second. And we multiplex 2 bits for each channel. So 2 bit, 2 here, 2 here, 2 here, 2 here. In order to create one frame, so 2, 2, 2, 2, 8 bit per frame. 8 bit per frame. So this one we have 100. But we combine 2 bit. So 100 divided by 2 equal to 50. So we get 50,000 frame per second. So in one frame we have 8 bit. So 8 times 50. So we'll get 400 kilobit per second or 400,000 per second. Okay, the next part we go for the empty slots under the synchronous TDM. So let's say we have 4 channels, but 4 devices that transmit the signal. But in certain time, only several channel that has signal. Only several devices that produce signals. For example, we have green, yellow, and pink. We have 4 devices. So only green, yellow, and pink send the signal. So we still allocate the empty slot for the channel number 2. Even there is no signal at here. So in synchronous, we still put together the empty slot. We still allocate the empty slot for the signal that doesn't have a signal during the process of transmission. Okay, the next part, we talk about the data rate management, the TDM. So one problem with the TDM is how we want to handle the disparity in the input data rate. Okay, before this, we discuss on the same data rate. We have 4 channel and 4 channel have 100 kilobit per second, but it has similar data rate. Now the discussion is how we want to do the TDM, but different channel have different data rate. Okay, for this part, we have 3 strategies that we can use or 3 techniques that we can use. The first one, we can have multi-level multiplexing. Okay, we have multiple level in order to do the multiplexing part. The second technique, we can multiple slot allocation. And the third one, we can use buffing technique. So this is how multi-level multiplexing being implemented. Okay, let's say we have 1, 2, 3, 4, 5 channels. However, these channels have different data rate. Okay, 2 channel has 20, another channel has 40 kilobits per second. That are the data rate. So what we can do, we try to multiply the first 2 because 20, 20, when we multiply, it's become 40. Then this 40 will be multiplied together with the rest of the channels. And then transmit the 160 kilobits per second. Okay, this one, what we call as the multi-level in the multiplexing. Okay, the next one, multiple slot multiplexing. Okay, we have several channels, 3 of them using 25 kilobit per second, the data rate, and one channel we have 50 kilobit per second. So we have different data rate. So what we can do, we use multiple slot multiplexing. So at this part, we separate 50 kilobit per second into 25 kilobit per second. So the input with a 50 kilohertz data rate has 2 slots in each frame. That is multiple slot. Instead of we only put 1, 2, 3, 4. Now we create another slot. So we have 1, 2, 3, 4, 5. Okay, in our frame. Okay, the next part is pulse stuffing. Okay, let's say here, for example, we have the channel 2 has 50 kilobits per second data rate, and another channel only have 46 kilobit per second. Okay, based on the numbers, multi-level is not suitable. Multiplexing also not suitable. Multiple multiplexing also not suitable. So what we can do is the pulse stuffing until the rate goes to the 50 kilobits, then we multiply the channel together. Okay, so that's on how we do the TDM technique if the data rate are not similar. So framing, in a framing bit, one or more synchronization bits are added into the beginning of each frame. This one for the synchronization. So the synchronization bit called framing process, and this synchronization bit consists of 1 bit per frames and alternate between 1 and 0. So easy to identify which are the first frame, which are the second frame. So let's say here we have synchronization pattern 101. So the first frame we add another 1 bit for synchronization. So let's say this data being sent, and then we meet this bit, so we can recognize that this one is the synchronization bit. And then after this bit, it will start with the frame number 2. And then you meet 0. So 0 is another synchronization bit. And then after this bit, it must be the third frame. That is the framing bits. Okay. Another example here, we have 4 sources and each creating 250 characters per second. If the interleave unit is a character and 1 synchronization bit is added to each frame, find the data rate of each source, the duration of each character in each source, C, the frame rate, D, the duration of each frame, E, the number of bit rate in each frame, and F, the data rate of the link. So how to solve it? The data rate of each source is 250. So it creating 250 characters per second. So one character we have 8 bit per second. So 250 times 8 equal to 2000 bit per second or 2 kilobit per second. It's the data rate of each source. B, each source sends 250 characters per second. Therefore, the duration of the character is 1 over 250 seconds. Or C, each frame has 1 character from each source. So which means that the link needs to send 250 frames per second to keep the transmission rate of each source. Number D, the duration of each frame is 1 over the frame rate. Okay, this one is the frame rate. This one is the duration rate, 1 over the frame rate. And each frame carries 4 characters and extra 1 bit for synchronization. So that's mean each frame 4 character, 4 times 8 bit plus 1. So total of bits per frame is equal to 33 bits. Okay. And the synchronous TDM is being implemented in the digital signal service or digital hierarchy. So only refer to the digital signal, telephone services, and second generation of cellular telephone network that use the bandwidth of 30 kilohertz band or 6 users band. So these are the application of synchronous TDM. Okay, the next part we will discuss about the statistical TDM. Okay, thank you and Assalamualaikum.